We're at that point in the class now where we're ready to start what's called the power hours. Each topic on the math exam, arithmetic, algebra, geometry, and data analysis, will be studied in depth for 1 hour. Again, this is not everything you need to know about the exam, but it is the highest priority items. It's basically the best value that we could put into 1 hour. On arithmetic, we have 5 major topics to cover today. Some terminology and notation, ratios, a further discussion of fraction, decimal, percent conversions, large versus small numbers, and exponents. You can follow along with the handout. Terminology first. The words sum, difference, product, quotient, and ratio are each associated with an operation. The sum is what you get when you add 2 numbers together. The difference is what you get when you subtract 2 numbers from each other. And that has to come in a particular order, of course. If we talk about the difference between A and B, that specifically means A minus B. It does not mean B minus A. The product is the answer we get when we multiply 2 numbers together. The quotient is the answer we get when we divide them. And again, there's a particular order to that, as well as the word ratio, which also means division. So the quotient of P and Q would be P divided by Q in that order, P over Q. And the ratio of C to D is also written as a fraction in that order, C over D. Ratios are also often written with colons. We're going to expand on the specifics of ratios a little bit further below. Integer. The word integer is very popular on the exam, and the easiest way to describe integers are just to basically list them out. This is a list of integers. The integers include the natural numbers 1, 2, 3, 4, 5, ... continuing forever, as well as 0, and the negative whole numbers, negative 1, 2, 3, ... forever and ever. So they may be positive or negative, but they may not be decimals or fractions between the whole numbers. The GRE often uses phrases like consecutive integers. An example of consecutive integers would be like 8 and 9. Or if they ask for, let's say, 5 consecutive integers, that would be like 7, 8, 9, 10, 11. Consecutive meaning one right after the other. Consecutive even integers would be, for example, 4 and 6. And an example of consecutive odd integers might be like negative 9 and negative 7. A prime number is a number that is indivisible. Examples of prime numbers are 2, 3, 5, 7, and 11. Like, let's take the number 7, for example. You can't divide 7 by any smaller number, by any smaller whole number. Nothing goes into 7 evenly. So it's prime. Another way of defining a prime number is that it has exactly 2 factors, 1 and itself. The number 1, by the way, is not considered prime because it only has 1 factor. We should always be aware of the first 5 prime numbers. In other words, I would like you to know those numbers by heart and be able to come up with them quickly and easily. It's a really short list to memorize. And finally, for our terminology lesson, I want to clarify the difference between multiples and divisors. By the way, most of us call these factors. But for whatever reason, the GRE prefers to call them divisors. Anyway, the point is that students get these words mixed up a lot. So if I asked you for multiples of 12 or divisors of 12, I want you to make sure that you're not getting them mixed up. The multiple, think about the word multiple. A multiple of 12 is what you would get if you multiplied 12 by a whole number. So that would be like 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. We're not dividing, but we are multiplying by 12. When I ask students what multiples of 12 are, 90% of the time they say 2, 3, and 6 because they're getting it backward. I don't know why, but students get this wrong more than they get it right. The definition of a multiple of 12 is 12 times any whole number. That includes 12 times 1, which is 12. It also includes 12 times 0, which is 0. So every number has as multiples of itself, 0 and itself. Divisors or factors of 12 are what you would get if you divide 12 by a whole number, as long as the answer is also a whole number. So these always come in pairs. And the best way to find them is to just start with 1 and keep working your way up. 1, 2, 3, 4. Okay, so 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And when you start repeating yourself, you're done. Let's try this again for the number 28. So 1 times 28. 2 times 14. 3 times, in this case, 3 doesn't go into 28 evenly, so we skip it and go to 4. 4 times 7. 5 times, nope. 6 times, nope. 7 times, we already have the 7. When we start to repeat ourselves, we're done.